All right, well, I think everybody that's going to join is with us, so I will go ahead and start. I'd like to thank you for joining this webinar that is going to concern our QuietLine sound barrier system. My name is Steve Mitchell. I'm the founder of Noise Barriers. I'll be your host for this presentation. I hope that you'll find this informative. I'd like to start by kind of giving you a little commercial on why Noise Barriers barrier wall system should be your choice. Noise Barriers has in-house design capability, and we couple that with economical professional engineering services that are familiar with our product, which allow us to not only accurately and quickly bid projects, but also to prepare submittals and shop releases at a minimal cost and do it quickly. We've got the capability and desire to assist any consultant, architect, construction manager, or owner on any size barrier project anywhere in the country, be it ground-mounted or roof-mounted. Our typical scope of work includes the sound barrier approval and installation drawings. We include calculations from a professional engineer registered in the state where the project's going. We include the structural steel frame, the barrier panels, doors if any. If quiet louvers are necessary for ventilation assistance, or quiet-proof absorption panels are necessary to treat sound that might bounce off of a host building wall, we offer that as well. We also offer complete installation. So we really are your total turnkey supplier for barrier walls. Now, we prefer to supply the steel columns or other framework for the barriers for both ground-mounted and roof-mounted barriers, but sometimes others supply the steel. That's really up to the architect and the contractor. We're happy to assist with that design, and we certainly will interface our panel system with the steel framework supplied by others. On roof-mounted barriers, we want you to be open-minded, as there are many ways to execute the structural steel framework. You should always use the best panel for the job by matching the performance of the panel with the appearance that the architect wants. Don't force the wrong panel into the wrong application. And we have many options to choose from and variations of panel design. In fact, this could be a subject of a webinar all by itself, because we've done so many different types of situations on roof-mounted barriers. Point is, call us to provide design assistance. All right, so let's start with the main subject for today, and that is our QuietLine barrier system. We offer multiple panel designs for you to choose from. We offer our SL, which is our shiplap panel. We offer a shiplap panel with a reveal, clever names here. We have a shiplap panel with a reveal that's designed to conceal the structural steel framework. We call that our SLR concealer. We offer our V-Stack panel. We offer our QuietMod HH, which is a panel that has hard surface on both sides of the barrier. It's not typical, but it does come up every so often. And then we also offer our QuietMod panel in an HP configuration, which has a hard surface on one side and is perforated on the noise side. The purpose of today's webinar is to introduce you to our two unique barrier panel systems, specifically the V-Stack panels and our SLR concealers. I'd like to tell you about the evolution of the V-Stack panel. When we started the company in 2003, we offered one barrier design, basically the same panel as other suppliers. It was 2 feet high by a maximum length of 12 feet. Well, it wasn't long before architects came to us and said, can you make a panel taller or longer? The reason for this is to cover more space with less installation cost. We also saw the need for improved interface between panels. So what we came up with is we developed our V-Stack panel. This is what it looks like. The V-Stack panel rests between the structural steel columns to create the barrier wall. The panels can be 4 or 5 inches thick. They can be any height up to 58.5 inches high, nominally 6 or 5 feet. This is the highest in the industry. They can be up to 16 feet long, which is the longest in the industry. The panel-to-panel interface is a very thin butt joint. You can see that horizontal seam here. These are 3 panels stacked on top of some louvers. No fasteners are required to secure the panel to panel, nor to secure the panels to the support steel. This section just shows a typical V-Stack panel. You see we've got acoustic fill. It's sandwiched between a 16 gauge minimum solid face on one side and a 22 gauge perforated face on the noise side. The panel-to-panel interface is achieved through inverted V-shaped roll-form channel that forms the top and bottom of the panel so that the panels nest together and create a good acoustic seal. The V-Stack panel is designed to fit between either the flanges of the structural column, like you see on the diagram on the left, or in cases where there's a high wind load, where the wall is very tall, a larger column is necessary. So we either bolt or weld angles to the web of a column, and that creates a slot between the angle and the front face, or the inside face of the front flange, to create the slot for the panel to fit into. When we turn a corner, a 90-degree corner, so two walls meet in a corner, what we do, you see in the right-hand diagram here, we've welded a couple of angles to the back face of the flange of the corner column, creating a 90-degree turn. We can also put those angles in at whatever angle is necessary to create either an obtuse or acute angle for the wall to make a turn. So we can meet whatever the lay of the land is or whatever the conditions on the roof are. So walls do not need to be straight and have right angle turns. Remember I mentioned that we don't need any fasteners to put our panel together. These are some photographs of a project that was done out in Colorado by a competitor. You can see that they have fasteners to attach panel to panel. If you look at the left photograph, they also have fasteners attaching the panels to the structural steel. We don't need any of that. Can you just imagine how many fasteners this required and how long it took? And really the bad part about this type of installation is you've now drilled holes in a finished painted surface, and that's going to rust. So the life expectancy of this wall is not going to be good. All of our barrier panels can be installed without the need for fastening them together nor fastening them to the structural steel. I want to share with you a couple of photographs of typical projects. The photo on the left is a 30-foot by 40-foot by 20-foot high barrier around some standby generators at a hospital that you see in the background. Those are patients' rooms. And just to the left of the red truck, there's an alley and backyards of residents that are across the alleyway from these standby generators. So the installation of this barrier enabled the people to not be disturbed by the generators. What I like about this photograph is you see several things we talked about in the design. You see the butt joint where the panels join together. You see how the panel fits into the vertical columns. You see the detail at the corner. You also see that we're able to put a door into this application. We can add doors to any barrier wall, so there's maintenance personnel have access to the equipment. The photo on the right is a wall that's L-shaped, 24 feet by about 170 feet long. It's 12 feet tall. It is going to protect all those residences and those apartments you see to the right from the mechanical equipment that's going to go where all these white packages are. So again, what we're able to achieve here is a tall and high spans with a minimal number of columns and the minimum number of panels to achieve the barrier. Sometimes architects have asked us to put cladding on our walls. I wanted to show you an application like that. In this particular rooftop barrier at a college in Chicago, on the left you see the V-Stack panels. They're unpainted. To those we mount the hat channel in the center photograph that the cladding panel is then attached to. Turns out that this cladding, doing it this way, was actually less expensive than powder painting the entire wall. And what it achieved is to have a continuity between the barrier walls and other penthouses that are up on the roof that we had nothing to do with. You can see that in the to the right side of this photograph, just above the beige brick wall, is a penthouse. That's not one of our barriers, but it's got the same siding. So the architect was able to maintain a uniform aesthetic appearance to this. As a side note, the green field that you see there is actually wildflowers. I like to get this photograph when everything was in bloom, but this is part of the Chicago green experience or initiative to have rooftops with planted vegetation. So it's a very attractive wall on top of a very attractive roof. So typical uses for the V-Stack panel are in applications where aesthetics aren't quite as critical, because the panels are larger, typically, and longer. It provides a lower square foot cost barrier than other designs. It's excellent for applications that require long walls. The 60-foot length requires fewer columns, fewer foundation piers, fewer panels to install, all factors that will reduce the labor time and overall project costs. In applications for higher walls, V-Stack is also excellent because the 5-foot panel height results in fewer panels that need to be lifted into place vertically, resulting in a lower overall cost. I'm going to show you an example of that. This is the old way we used to do these walls, 2 foot by 12 foot. You see this is a 48-foot long wall. It is 20 feet tall. There are 4 bays of panels, a total of 40 panels, and 5 columns. Each of those panels takes about, without our lifting mechanism that we've developed, which we'll show you later, each of those takes about 20 minutes to put in. So it takes a long time to put this up. There's a lot of lifting that has to be done. And of course, there's 5 columns. We can do the same length and height wall with our V-Stack panel by making the panels 5 feet high by 16 feet long. It reduces the number of bays from 4 to 3, reduces the number of panels from 40 to 12, and reduces the number of columns and piers from 5 to 4. All of that saves a lot of money. Each of these panels can be set in place in under 10 minutes. So it's a much faster installation. And again, we're going to show you a video shortly that will demonstrate this. So the V-Stack became a very popular and successful panel for us, but we did eventually have architects come to us and say, can you give us a panel that's more linear appearing, going back to the old way we used to do it? And we came up with our shiplap panel. That panel we introduced, it was successful. Many architects used it, but other architects said, can you add a reveal to that so we can kind of tie it into the appearance of the building? So we developed our SLR, which is a shiplap panel with a reveal. Wasn't too long after that when somebody said, is there any way you can make this panel conceal the structural steel instead of slipping down between the flanges? So that's when we developed our SLR concealer, and this is what it looks like. The concealer panels are designed to conceal the column by sliding over the column flange. These panels are typically 5 inches thick. These panels are generally 24 inches high. We can go a little bit higher, but typically 24 inches. They can be up to 16 feet long. The panel-to-panel interface, both horizontally and vertically, is a 1-inch reveal, which you can clearly see in this photograph. No fasteners are required, again, to secure the panel-to-panel in order to secure the panels to the support steel. Creates a very attractive looking wall. In this section, again, we have acoustic fill sandwiched between a solid skin and a perforated skin. In this panel, we achieve the panel-to-panel interface by a channel that we make, creating the 1-inch reveal that you see between the panels. The difference, though, with this panel is how it connects to the structural steel. Right in the middle of this, you see some wording where it says 3/4 inch wide by 2 inch deep notch in SL channel. That slot that we built into the panel allows this panel to slide down over the wide flange beam flange. You also see in this section, or this diagram, a 3/4 inch by 3 inch deep notch in the SL channel for lifting. I'll show you what this is used for in a few minutes on how we lift these panels into place. So this is what it looks like. In option 1, you see that the panel is now, rather than fitting between the flanges, it covers the flange, creating a 1-inch reveal vertically, and then you'll have the 1-inch reveal horizontally, because the panel slides over the flange. That secures it in place, so no fasteners are necessary. In some installations, we have this option 2, where the architect actually wanted the wall to hang over the host building wall just a little bit. And this was achieved by welding a structural T to the flange of the support column. And then the panels were installed proud of the host building wall. You'll see that in just a second. Another major difference of the SL, our concealer panel, is how we do the corners. We actually have a preformed corner, a 2-foot by 2-foot corner panel that is designed to create a sharp right angle turn. We can also do acute or obtuse angles as well if a wall is going to have a right angle turn to it. But this is what the corner looks like. And here it is in an application. This happens to be at a school in a suburban community. Immediately to the left of this barrier are homes that were affected by new mechanical equipment that was installed on this roof. The architect wanted the panel to hang out over the wall a little bit. So this is where we use that detail that I showed you in option 2 a couple slides ago. Please notice the uniform horizontal and vertical reveals. Please notice the finished corner appearance that we get. And you can see here on the far side to the left, we also can include a door in this panel system as well. So the difference between the concealer and the other way of doing it is what you see with these 2 photographs. The photo on the left is basically a 2-foot by 10-foot long panel. And you can see that it's the panels are slid between the flanges of the column. You see you have an exposed corner, and you can see the structural steel. If we'd had the concealer at that time, the look they would have had is what you see on the right. I think we can agree that that's a much cleaner line and is much more attractive. The other advantage of the concealer panel is it can really complement the building architectural design. Here you see the horizontal and vertical reveals are in concert with the horizontal and vertical lines that the architect has designed into the building windows and face of the building. So it complements the building very well. It doesn't stand out there like a sore thumb that has been added, but in fact looks like it's part of the original design. The typical uses for the concealer panel are applications where aesthetics are more critical. We can match the reveal in a building design. We can conceal structural support system. The preformed corner panels provide a nice finishing detail. This panel is excellent for applications where weight's a factor, because this panel can be constructed using lower weight aluminum when barrier weight is critical. It's excellent for walls then that are going to be exposed to the salty air around the ocean. This system provides a cleaner appearance than other panel profiles. And applications for long walls, the capability for 60-foot long panels, again, requires fewer columns, fewer foundation piers, fewer panels to install. But again, these are all factors that reduce labor time and overall project cost. With regards to the acoustic performance of these 2 wall panels, they're both very similar. The V-Stack has an STC of 38. The concealer panel has an STC of 37. This is better than our old original panel was by several points because of the V-Stack interface or the shiplap interface that we came up with. In both cases, the noise reduction coefficient is a 0.95. So these are both better than most panels in the market. and are very similar. So you could use these, either one of these in any application that you have. I want to talk a little bit about installation. We're real concerned about safety for installing walls. This is the old way that panels would be installed. You see there's two men on the ground here on the left, the guy in the blue shirt bending over, the guy in the white shirt. They would need to lift this panel out of the crate. They need to prop it up so they can wrap those straps around it so the hoist can lift the panel into place. The two men up top there guide the panel into the column. And then as it's lowered into place, they have to put a couple of pipes or 2x4s on top of the panel that's what do you look at, 1, 2, 3, 5 panels up. And the new panel would be set on top of that pipe or 2x4 to leave a space for the straps to be released and pulled out. And then you pull out the pipe or the 2x4 and the panel drops into place. Not only is this time consuming, it's incredibly dangerous. It's very easy for a worker to get a finger or a hand caught in there. Noise Barriers is committed to safety. Noise Barriers was started by a bunch of old reps that also went out and installed these projects. So we've always been very concerned about what's a better way to lift the panel into place. And what we came up with is that lifting slot that you saw on that slide earlier. The way this works is the crate arrives on site, like you see in the photograph on the left here, in the left circle. The panels are on their edge. One worker just attaches a hook to either end of the panel. Hoist then lifts the panel into place, and it slides down to rest on the panel underneath it. And then the workers just have to reduce the remove the clip from the lifting slot, and the panel fits snugly into place, and no fasteners are necessary. This is a much safer and a much faster method of installing these panels. We have a short video I'd like you to view with this. This particular video is, will show you how the panel gets lifted into place. This is available for use by contractors if they want to install the panels themselves, or by architects.
Introducing QuietLine V-Stack Barrier Walls by Noise Barriers. An easier, safer way to install noise barrier walls. Please review the installation packet in the crate and consult the install documentation for a list of tools needed. Columns are set in place and fastened to existing or precast anchor bolts. When the V-Stack crate arrives at the job site, it is placed on level ground and braced so it won't tip over as load becomes unbalanced. Before removing the first panel, clamp the remaining panels together to prevent them from falling over. The V-Stack panels feature built-in slots for easy lifting and are designed to be lifted directly out of the crate. While competing systems require 2 workers to lift, temporarily support, and install straps for lifting. The panel is lifted and guided between the columns, coming to rest on the base plate. The hooks are then simply removed to complete the panel installation. Other systems require 2 workers to perform the tedious and slow process of temporarily supporting, unstrapping, and then placing panels. V-Stack installation requires no fasteners. There is no time wasted supporting, strapping, and unstrapping panels. Simply unhook and stack. To build better, smarter noise barrier walls, visit us online at noisebarriers.com.
So that shows just how easy it is to install these walls. A typical panel that's strapped, you need, besides the person in the hoist, you need 2 men on the ground, you need 2 men up high to guide the panel into place. And it takes in the neighborhood of about 20 minutes to set a panel. With this lifting slot, you need 3 men, and they can set a panel in under 10 minutes. And it's much safer, so you're using fewer people, and it's quicker, and it's safer. These 2 photographs are the V-Stack panel with louvers on the left, and on the right, you see the concealer panel. This building on the right is a mechanical building at Penn State University. That wall is up on the roof is 30 feet tall. It's over 500 feet long. The crew was setting over 65 panels a day. And look how high they were working. The beige panels are just some perforated panels we provided at the architect's request or design to break up the solid look of the wall. This lifting slot mechanism that we use is available on and as a standard part of all of our barrier wall panels. So a few things that V-Stack and concealer panels have shared traits on. They both are constructed of 16 gauge solid skin and 22 gauge perforated skin, sandwiching the acoustic fill. We can go with heavier gauges if necessary. Standard materials are G90 spangled galvanized for weather resistance. We can use A60 galvanneal steel, stainless steel, or aluminum if required. When we make panels that are over 48 inches high, we include additional internal stiffeners to accommodate the high wind load requirements that the professional engineers require. No fasteners, again, are required with either panel system to secure panel to panel or panel to support steel. Some other wall manufacturers require fasteners every 12 inches only to panel joint. And as we saw earlier, it's not only expensive to install, but unsightly as well. Our walls are all available with a durable power paint finish, any standard RAL color. We can custom match colors if necessary. We have the longest warranty in the industry with 5 years for materials and 10 years for the finish against peeling and cracking. All of our barrier panels include weep holes along the bottom edge for water runoff. Some walls may require personnel doors, we said earlier, or a single or double leaf door for equipment access, or they may require louvers for additional ventilation. We can handle all that. In some applications, it's necessary to put absorption on a wall that is adjacent to a host building wall where the sound might hit that host wall and bounce over it. So we treat that with our QuietPerf absorption panels. And generally, acoustic fill is not encapsulated. It does not need to be because it naturally sheds water and it won't deteriorate. But in applications where bag fill is required, we can provide that. We've developed 3 different pieces of literature depending on the market that somebody's addressing. We have literature that addresses barriers for the architectural and industrial applications. We have literature specifically geared towards the power and electric utility industry. And we also have literature that deals more with transportation applications. So the advantage of our barrier walls is we have turnkey capabilities. We do the design, the PE stamp, the structural framework, the barrier panels, the doors, the absorption if necessary, and installation services. Most importantly, we listen and we're flexible. We've developed these products because customers came to us and said, hey, can you help us achieve this appearance? We offer the longest and tallest individual panel sizes available, which reduces material, steel, and labor costs. We've developed a fast and very safe method of installing panels. And we have 6 different panel configurations to meet architectural and acoustic performance requirements. Applications that are long or high, use the V-Stack. It's by far the most economical panel system on the market. If you need something that's more aesthetic, the SLR concealer is the best looking panel system on the market today, and we would encourage you to use that. Please make note of this email address, marketing@noisebarriers.com. If you have questions about the V-Stack and concealer barrier panels that we discussed today, or if you want to receive sample specifications, drawings, or budget pricing, if you want to talk about or have questions about any of our noise barrier products, or if you want a sales rep to call you to assist you on a current project, please reach out to marketing@noisebarriers.com, and we'll get somebody to follow up with you right away. I want to thank you for attending this. I know your time is very valuable, and I appreciate that you've spent some of it with me today. Thank you very much.